Video for day 34. It's Stoichiometry 2, and this is the revised version, so that's the one you should have. Alright, there was a pre-assignment, but it wasn't a problem I actually intended to give, so I didn't complete it. So that's something that you don't need to do. So we're going to move on to this problem one, which is on page 2. Alright, so the first thing you do is you need to compute the molar mass as if they're not given to you. I will go ahead and do one of them. Okay, so we have 2 carbon right here. Periodic table. Carbon is 12.01. And 4 hydrogen. And from the periodic table, the atomic or molar mass is 1.01. And when we add those, we get 28.06, and that's grams. Okay, so we can put that right here. I don't leave a lot of space there, so you can just put it up here. Okay, so now I'm going to move ahead. O2 is 32. CO2 is 44. And H2O is 18. Okay, and these are all grams per 1 mole. Don't get confused by the moles up here. They don't have anything to do with molar mass. Molar mass is always 1 mole. So for water, no matter what problem you do with water in it, H2O, it's going to be 1 mole equals 18.02 grams. Okay, let's move on. Alright, so first question here is how many grams of H2O will be produced by 3 moles of C2H4. So you find grams. Grams is in the grams row, and it's H2O, so it's going to be right here where H2O and grams intersect. So that's going to be the question mark. That's what you're looking for. 3 moles C2H4, so that's the moles row up here. C2H4 is here, so they intersect right there. That's where the 3.5 is going to go. Alright, so you need a path from what you know to what you don't know. You can only go sideways inside the chemical equation because it's the only place that we know relationships. This is 1 mole C2H4, 3 moles O2, 2 moles CO2, 2 H2O. So it's the only relationships. You don't know relationships of grams. Alright, so we go across from here to here. That's one conversion. And then the second conversion is we go from this box down to our question mark for our final answer. So it's going to be a two box problem here. So over here we'll write what we're looking for, grams H2O, and what we're given is 3.5 moles of C2H4. And it's going to be 2 boxes or 2 conversions. Okay, so the first one is going to be the moles to moles conversion inside the chemical equation. Everything up here is in moles. So you simply read it directly out of the chemical equation. You're interested in the relationship between moles of C2H4 and moles of H2O. We don't care for this problem about O2 or CO2. So there's 1 mole of C2H4. You just read it exactly here and you add the word mole. 1 mole C2H4 equals 2 moles H2O. So we'll write our equivalency down here. I'm going to write it over here so I don't run out of space. And now I can write 2 conversion factors. I do ask you to do that for the day 34 assignment. It's a lot of writing, but you only do it for this one assignment. Okay, so you have one of these to choose from. Again, what we did was we put this one over this one, that's right there, and then we flipped it. We put this one over this one, that's right there. So which one do you want to go in that? It's just very simply, whatever you have here in your starting value here, that's what has to go on the bottom here so it cancels out. So mole of C2H4 goes on the bottom, so it's going to be this one that you're going to choose. Moles of C2H4 cancels with moles of C2H4. So now you're sitting in this box. You do not do that calculation right there. Show you again, show you where you are. You're in moles of H2O. Okay, now you need to get from moles of H2O out to the question mark. And what's in between those two boxes is the molar mass conversion. So that's your equivalency right there. All right, so we're going to choose one of these two to go in here. Which one is it going to be? Well, you have moles of H2O on the top here, so moles of H2O has to go on the bottom here. So we are going to pick the moles of H2O on the bottom, not grams of H2O, moles. So it's going to be this one right here. So moles of H2O cancels with moles of H2O. The last man standing is grams of H2O, and that matches up with the units that we were trying to find, so we know we've set the equation up correctly. So now we can go ahead and we multiply everything on the top. 3.5 times 2 times 18.02, and we divide by everything on the bottom. Divided by 1, divided by 1. Of course, you don't really have to do the divided by 1s, but if whatever is down there should be divided by. You don't have to do them because it doesn't change the value of the answer. And that gives us 126.1. Again, just go one place after the decimal. Usually that's good. I'm not worrying about significant figures here. Okay, and that's your final answer. So that's how many grams of H2O you would end up with. Okay. All right, the bold-faced are the ones. It says how many moles of O2 is required to produce 8.3 grams of CO2. So moles of O2 is what we're looking for. We're trying to get to 8.3 grams of CO2. So moles of O2 up in the moles row, that's in the chemical equation, and there's O2. So that's our question mark. That's what we're trying to find. Grams of CO2. So here's CO2 and here's grams down here. So that's where 8.3 goes. Okay, so now this is what we know. This is what we're trying to find. So we have to go up and over like this. Okay. Up and over like that. So our first conversion is going to be the 1 mole equals 44.01 grams for CO2. So that's our first conversion. So let's go ahead first and write moles of O2, so way over here. Grams of CO2. And again, it's 1, 2 different directions of the arrows up and over, so that's 2 boxes again. Okay, so which one of these two goes in the box? Grams of CO2 on the top here. Grams of CO2 has to be on the bottom there. So it's going to be the first one. Okay, and they cancel. And now we come on over here. So now what we need to do is get from moles of CO2. We're now in this box right now. We need to get from moles of CO2 to moles of O2. So it's a moles to moles conversion. So you simply take it straight out of the chemical equation. 3 moles O2 equals 2 moles CO2. Okay, choose between these two for that. You have moles of CO2 on the top here, so moles of CO2 has to go on the bottom there. So it's going to be this one. Last man standing is moles of O2. That's what you want in your final answer. So multiply 8.3 times 1 times 3 divided by 44.01 divided by 2. So we'll go ahead and do that. And that gives us 0.28. I'll go to an extra digit there because it's only a decimal number. And that's your final number. That's how many moles of O2 you would end up with. Okay, now we're moving on to letter D. How many moles O2 are required to make 12.52 grams of H2O? So we're looking for moles of O2, moles row, O2, question mark. Grams of H2O. So down here, question mark. Or excuse me, down here 12.52. 12.52 grams H2O. So So path from what you know to what you don't know, here to here, so it's up and to the left. So your first conversion is going to be the molar mass conversion for water. So let's first of all, though, write out our equation. So what we're trying to find is moles of O2. So it's going to be way over here on the right. And what we start with over on the left. It's a 2 conversion problem, 1, 2. All right, so now we say the first conversion, first equivalency we need is the molar mass conversion here. So it's 1 mole equals 18.02. Okay, which one goes up here? Grams of H2O here, so grams of H2O has to go down here. So that's going to be the first one right here. Cancel and cancel. Now we come over here. Now we've got to move from moles of H2O to moles of O2. So again, it's 3 moles of O2 equals 2 moles of H2O. Okay, which one? Moles of H2O, moles of H2O. So moles of H2O cancels there and there. Last man standing is moles of O2, which is what you need in your final answer. 12.52 times 1 times 3, everything on the top, divided by 18.02 divided by 2. We get 1.04 for the final answer. And there you go. Okay, next problem. How many moles of O2 will be needed to produce 5.67 moles of H2O? So moles O2 and moles H2O. So how many moles of O2? Moles row, O2 right here is question mark. 5.67 moles of H2O. So this is going to be, going back to lesson 33, a 1 conversion problem. It's moles to moles. That's all you need to know. Alright, so we're going to go ahead and set it up. Okay, it's just a 1 conversion problem. So you just need 1 box. Might have been tricked because you thought there must be a trick to this, but no. It's just going back to the same type of problems we did in the last assignment. Alright, you don't need this space at all. Okay, so the equivalency we just said. 3 moles of O2 equals 2 moles of H2O. Choose from one of these. Moles of H2O on the top means moles of H2O has to go on the bottom. Last man standing is moles of O2, which is what we need for our final answer. So it's 2 times 3 divided by 2, and that's simply going to give us 3. So that was a pretty quick and easy one right there. Okay. Alright, so I'm going to give you the answers to the problems that I left for you to do, but these are the ones I'm going to check. You have to show all the work. So it's 323 grams of CO2 is the answer to 1B. And for 1F, it's 0.23 moles of C2H4 for this one. Okay, so show all the work that I showed in the problems up above, and I'm going to check those problems. Alright, so we are now moving on to problem number 2. So grab your periodic table and the molar mass of sodium. It's just a single element. It's not 2 sodium, it's just 1 mole of sodium. And that's going to be 22.99. Okay, let me see if I can fit it here. It'll be a little clearer. Water is 18.02. Sodium hydroxide is 22.99 plus 16 plus 1.01. That turns out to be exactly 40. 40.00, but I'll leave it like that. And H2 is 2.02. Okay, so I'll get rid of that. So those are the ones that you're going to need. That's what you would compute here. All right. So how many moles H2O are needed to produce 4 moles of NaOH, sodium hydroxide? So moles H2O, okay, and that's what we're looking for. So you come over here, it's moles row, and you find H2O, it's right there. And 4 moles of sodium hydroxide. So moles again, and there's 4 in sodium hydroxide. So it's again a one conversion problem here. So we're going to try to find moles of H2O. Since it's just one conversion, we need just one box. Alright, so the conversion is going to be, again, anytime it's in the moles row, moles to moles, it's straight out of the chemical equation. 2 moles H2O equals 2 moles NaOH. Alright, so you choose from one of these to go up here. You need moles of NaOH here, so you have moles of NaOH here, so you need moles of NaOH down here. That's going to be the first one. Okay, so moles of NaOH, moles of NaOH. Last man standing is moles of H2O right there. So it's 4 times 2 divided by 2 is 4. Here's the answer to it. You show all the work. 274.5 grams of sodium is what you should end up with that problem. Okay. Alright, I didn't give you much room for this problem, so let's see if we can squeeze this in down here. How many moles of H2O required to produce 3.32 grams of NaOH? We come back up here. I'm going to have to move this back and forth a few times. Moles of H2O is right here, question mark. Grams of NaOH is right here, and that's going to be 3.32 from the problem. So we have 2 conversions. We have to go up through the molar mass to get to moles of NaOH, and then laterally sideways over to moles of H2O. Alright, so let's go ahead and set up the equation. Okay, since you don't have much space here, and that's my fault, I'm going to let you get away with just writing the equivalencies and not the conversion ratios here. That's what you'll be doing on lesson 3 anyway, but let's go ahead and just write those. So you'll learn how to find the conversion factors from the equivalency. So here we go. It is, first one we need is to get into the chemical equation. So it's the molar mass. 1 mole equals 40 grams for NaOH. Okay, so what you're simply going to do is pick which one of these do you see here. You see grams of NaOH, so that has to go on the bottom. So grams of NaOH right there. Okay, so now we are sitting in this box right here, and we need to go across to, we're in moles of NaOH, we need to go to moles of H2O. Again, the equation tells you what that relationship is. 2 moles of H2O equals 2 moles of NaOH. Alright, so what we have up here in this, on the top here has to be on the bottom here. That's moles of NaOH. Okay, moles of NaOH, moles of NaOH. Last man standing is moles of H2O. There it is. Alright, so it's going to be 3.2 times 1 times 2 divided by 40 divided by 2. And that is going to give us 3.32 times 1 times 2 divided by 40. It's going to give us 0.83. So let me say that again. 0.083, and that's moles of H2O. All right. Okay, so we're on to D, and that's a problem for you to solve. And there's the answer to that problem, 0.065 moles of Na, sodium. So you do all the work, show all the work, equivalencies, conversion, factors, everything to do that. Okay, we'll move on to the last one then. Here is E. Okay, so how many grams of H2O will be produced by 5.67 moles of H2O? So we're trying to find grams of, H2 I said. It should be H2. How many grams of H2? So we're trying to find grams of H2. So here is the grams row, and here's H2. So that's the question mark. And we're starting with moles of H2O. Moles row, H2O. That's the 5.67. So we need to go from what we know. We're going across from moles of H2O to moles of H2, and then we come out through the molar mass of molar mass of H2 to get our final answer of grams of H2. All right, so let's set up the equation up here. Okay, and we see we have two different arrows, so it's going to be a 2-box problem. All right. Okay, so what we do first is we go from moles of H2O to moles of H2. You see the relationship there? There's 2 moles of H2O equals 1 mole of H2. Let's put that down. Okay, one over the other and then flip it over. Which one goes up here? Moles of H2O up here, so you need moles of H2O down here. So it's going to be this one. Okay, now we need to get from moles of H2 out to the grams for our final answer. You use the molar mass, just use the box that's in between those two, which is this one right here. 1 mole H2 equals 2.02 grams of H2. Okay, so you got to choose one of those. You have moles of H2 on the top here, so moles of H2 has to go on the bottom there. It's going to be this one. Okay, cancel, cancel. Last man standing is grams of H2. So it's 5.67 times 1 times 2.02 divided by 2 divided by 1. And that gives us 5.7. Right there. Okay. All right. And the last one in this set is the one that I did with everyone in class. I'm not going to do it on this video. If you didn't do this with me, you missed class, you can come to me in tutoring and I'll work this one with you. It's one that I want to see you. Okay, the last problem is required for the honors students. Extra credit for everyone else. I'm only going to give you answers for this one, and you need to do all of these on your own, but I will give you the answers. All right, so for problem 3, here are the answers. This is day 34 revised, and this is problem 3, required for the honors students and optional for the regular chem students. So part A, the answer is 3.9 moles of O2. Part B is 10.1 grams of CO2. Part C is 0.27 moles of H2O. D is 9.12 moles of O2. E is 0.72 grams of O2. And F is 0.046 moles of H2O. So that takes care of this problem set, and get this in by Monday, and we will move on to the Stoichiometry 3 on the next assignment.